A new study has just reignited one of science's most exciting questions. Could we find life beyond Earth? This time, the evidence comes from Saturn's small but fascinating moon, Enceladus. NASA's Cassini spacecraft, which orbited Saturn for more than 13 years, collected priceless data during its mission. Now, researchers say those decades-old measurements hold something new. Fresh proof of complex chemical reactions happening beneath Enceladus's icy crust, and that chemistry may be laying the groundwork for life. Back in October 2008, Cassini flew through plumes of ice shooting out from fractures near Enceladus's south pole. These icy grains were moving fast, striking the spacecraft at nearly 11 miles per second. At those speeds, Cassini's mass spectrometer could separate the chemical fragments inside the ice much more clearly than in slower passes. What the team found is remarkable. Fragments of complex organic molecules, including aromatics, esters, ethers, and alkenes, plus possible nitrogen and oxygen-bearing compounds. In simpler terms, these are building blocks of life. Lead researcher Nozer Kawaja from Freie Universität Berlin says the findings strengthen the case that these molecules come directly from Enceladus's hidden ocean, making the moon even more promising as a home for life. You see, Enceladus constantly sprays water into space, creating Saturn's faint outer E-ring. Grains in this ring can spend years exposed to space radiation, which scrambles delicate molecules. But the fresh grains Cassini sampled had just been ejected minutes earlier. They represent a far more accurate snapshot of what's happening deep below the ice. And what they reveal is chemistry that is not only active but diverse, exactly the kind of chemistry that can fuel biological processes under the right conditions. We already knew Enceladus has liquid water beneath its icy shell. Earlier studies detected tiny silica particles, a sign that hot water was circulating through the rocky seafloor, just like hydrothermal vents on Earth. Cassini also measured hydrogen gas erupting with the plumes. On Earth, microbes use that kind of hydrogen as an energy source. Now, with the discovery of these new organics, the case grows stronger. Enceladus seems to have nearly all the ingredients scientists look for: liquid water, a source of energy, and a wide range of chemical building blocks. One especially exciting find is phosphorus, detected in earlier analyses of Enceladus's ice. Phosphorus is rare in most planetary oceans, but essential for life on Earth. Together with carbon, hydrogen, nitrogen, oxygen, sulfur, and now phosphorus, known collectively as CHNOPS, Enceladus checks off the list of life's fundamental ingredients. Of course, Enceladus isn't the only icy world in the spotlight. Jupiter's moon Europa also hides a vast ocean beneath its crust. But there's a key difference. Europa doesn't have the same active jets shooting material into space. That means getting a direct sample from Europa's ocean will be far more challenging. NASA's upcoming Europa Clipper mission will investigate its surface and atmosphere, but Cassini gave us something Clipper won't have: an open window into an alien ocean. That makes Enceladus one of the most tantalizing targets for the search for extraterrestrial life. This new study also teaches valuable lessons for future missions. Cassini showed that fast impacts of ice grains revealed organics that slower passes might have missed. That means future spacecraft can be designed to sample these jets even more effectively, collecting single grains, broadening mass ranges, and combining results with gas measurements. Some mission concepts even propose flying through the plumes again, or landing near the icy fractures themselves to analyze the frost directly. For now, the question remains unanswered. Does life exist on Enceladus? These latest findings stop short of claiming biology, but they do show a world that is active, chemically rich, and potentially habitable. And that's why many scientists see Enceladus as one of the best chances humanity has at finding life beyond Earth, whether in the form of microbes or simply in the chemistry that could one day give rise to them. From a small moon orbiting Saturn, we are reminded of something big. The possibility that we are not alone may not be a distant dream, but a reality waiting just beneath the ice.